Alright, for the next part, we're going to do examples 3 and 4 and then take a few more notes. So on part 3, or example 3, what we've got, we're looking to find the value of x, y, and z, and it says to write the property of parallelograms used for each. Alright, well, looking at this, the figure is not drawn to scale, so you might want to make a note of that, not drawn to scale. So if something doesn't look quite right, that's the reason why. Okay, so we've got x, y, and z over here on this side of the parallelogram. Now then, keep in mind that consecutive consecutive angles are going to be supplementary. Okay, so if this angle is 105 and this section is 144, we need x to complete the 180 degrees. So we've got 105 plus 44 plus x has to equal 180. Alright, so when we go to solve that, you've got 149 plus x equals 180. Subtract 149 from each side and you will get 31. Okay, so x would have to equal 31 degrees. Alright, and then the property of parallelograms that we just used is consecutive angles are congruent. And I condensed that down for you. Consecutive angles are congruent. Alright, now then, opposite angles are congruent. Okay, so this angle here, both of those added together would equal 75. So these two angles here must add up to 75. So in order to find y, you could say that 31 plus y equals 75. Subtract 31 from both sides and you would get 44. Another way to look at this is you've got a parallelogram, so these sides right here are parallel. This diagonal would act as a transversal, so you've got alternate interior angles are congruent, and that would be something from the past in chapter 3 if you remembered that. If not, you could just write yourself an equation and solve for it. Okay, so y would equal 44 degrees. Okay, and what rule did we just use? Opposite angles are congruent. Okay, and that's how we went through and solved for that one. Now then, z, easy to find that. It's opposite of 105. So z would have to equal 105, or we could say it's consecutive with this angle, and they have to be supplementary. So you can look at it two different ways, but this one's easier. Opposite angles are congruent. Alright. So that's using those properties of a parallelogram and used to solving problems. Now then, example 4, explain why each figure is not a parallelogram. Now granted, some of these are a little hokey looking and everything, but you would have to understand that it's not a parallelogram on the first one based on the fact that opposite sides are not congruent. Okay? So, it's not a parallelogram, opposite sides not congruent. Okay, looking at this one, you've got diagonals that intersect, and when your diagonals intersect, they bisect each other. Therefore, each half should be equal. These are not equal. So the diagonals do not bisect each other. Bisect is the key word there. They intersect, they just don't bisect. That cuts it in half. And then the last one, okay, what's wrong with these? Well, this is not going to happen because if it's a quadrilateral, all your angles have to add up to 360 degrees. But these only add up to they're 20 short, so 340. So these add up to 170. So basically what we're saying is consecutive angles are not supplementary. So if that's the case, then you do not have a parallelogram. Okay? All right, now, the very last part. This is proof that a quadrilateral is a parallelogram. So if we were writing proofs, this is some information that we would need, okay, or for problem solving. So first of all, both pairs of opposite sides are parallel. Then it is a parallelogram. So that's how we're going to look at this. We're just writing the converse of the original statements. Because before we would say a quadrilateral is a parallelogram if both pairs of opposite sides are parallel. Now we're saying both pair of opposite sides are parallel, therefore it is a parallelogram. And once you've made that statement, then all of these other statements are to be true as well. So it's just the converse of what we wrote down on the other side. So when we draw these pictures, they're going to be representative of the exact rules that we wrote down for the first part of the lesson. Okay? Both pairs of opposite sides are congruent. All right, so draw your parallelogram and mark opposite sides to be congruent. Both pairs of opposite angles are congruent. Opposite angles are congruent. Here we go, here we go. Booyah, booyah. Then it's a parallelogram because this is true. One pair of opposite sides are congruent and parallel. If you just know something about one side, one pair of sides, but what you know is that that pair is parallel as well as congruent, then you can say it is a parallelogram. Now, if you just know that they're parallel, you can't say it's a parallelogram. Or if you just know that they're congruent, you can't make that statement. But if you know both of these are true, then you can go ahead and say it's a parallelogram and know that all the other characteristics of a parallelogram apply. And then number 5, if the diagonals bisect each other, then it is a parallelogram. So if these diagonals bisect each other, boom, 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 then it is a parallelogram. So in all of these statements, we're saying it's like an if-then statement. If this is true, then it is a parallelogram. Okay? So you're just creating an if-then statement, the converse of what you had stated on the other page right here. All right, that's it for 8.2 and 3, the characteristics of a parallelogram, and I'll see you later.